What do you mean take out the product? You factor out of y prime, right?
Yeah.
Right. So how did you come from this step, this last step? Can you see my pointer? Maybe no. Oh, okay.
Wait, no, I can't actually.
Oh no. Okay.
No.
How do you? So the very bottom one, the very bottom line, right?
Yeah.
How did you go from the very this bottom line to your result to this y prime you square?
Yeah. So there is a negative sign in front of the fraction here.
Yeah.
But so over here we have negative 3xy squared times y prime plus x squared y prime. So we move the x squared to here, and then negative 3xy squared to here.
Okay.
Times y prime.
Okay. So my question is, how did you come from this step to your result?
I divided both sides by x squared minus 3xy squared, but I factored out the negative, so that's why it's in front of the fraction.
What do you? So when you when you divide by this x squared minus 3xy squared, right? 0 divided by anything will be 0 on the right left hand side.
Yeah.
But I don't see that. I just want you to explain to me from this step to your answer. What do you do to get this last step to your result, which you boxed it, the answer you boxed it?
I mean, then I isolated y prime.
Okay.
If that's what you want to hear. That's what I did.
No, that's something else. What did you do with the y cube? You see, right now, the last step, right? You have everybody on the left-hand side. Right, you won't have a 0.
I added, no, I added to the other side.
Right, you moved to the other side. That's what I want to hear.
I didn't know that's what you're asking. Okay.
Right. So you moved these terms without the y prime to the right-hand side. Then you have a positive y cube, positive y cube, right? Minus 2xy, minus 6x squared, right? Which is your numerator. Right? So now you divide by x squared minus 3xy squared, right? Then on both sides you divide by this. So that's why this negative sign does not make sense to me, because I don't know why you switch those two. So your denominator should be, you should ignore this negative sign up front. The denominator is x squared minus 3xy squared.
Okay.
Make sense?
Yeah.
Right. All right. And that's a cleaner answer also. So for this step, you should just forget about the equal sign up front. Move the equal to 0 move the equal sign to equals to y cubed minus 2xy minus 6x squared, right? Makes sense, right?
Yeah, a little bit more.
Okay. All right. So in that case, you don't have to, deal with the negative sign. Okay. All right. Thank you, Raphael.
Thank you.
Okay. Next one, 6. Kitty.
Yeah.
Yeah. 6, please.
Yes, I'm just trying to look for the file that I can't find.
I asked you to get ready before.
Oh, I'm sorry. Oh, I can't share my file. How would I be able to share it?
Okay, you see the bottom? First, open your file on your computer screen. Then you see on the right bottom, there's an arrow. You move your cursor to it, it says share content. So you click on it, it gives you 3 options. Choose the middle one, share application / screen.
Oh, share application / screen.
Yes. Okay, so Julie, please get yourself ready. Then 10, Fedora number 10, ruling number 8.
Is it working?
Number 2. I don't see it yet. Number 12, Angel.
No.
Number 14. Number 14, Ray. So please get yourself ready, okay? So we don't have to wait for let me make you presenters.
Hello, Professor. I think I'm doing number 14.
Number 14.
Malika.
Malika said first, 14, right? Yes,
Yeah.
okay, Malika. Yeah, you're right. You're right. Oh, 6. 6 actually, Karishma chooses 6. So Kitty, I don't think, Karishma, are you here?
No, I chose number 6.
I think Karishma is read on my chat.
Yeah, I can ask
I
her.
chose number 6 in the beginning. I can't get the screen to work. It won't let me share it.
So, but I see Karishma is read under my good morning. Do you see, Kitty, do you see in the chat? You see in the chat, Karishma chose 7 o'clock. But it seems like, Karishma, are you here?
Yeah.
Oh, you're here, right? Okay, are you ready to show?
Yeah.
Okay, go ahead. Oh, let me make you a presenter.
Why can't I show?
Okay.
So prepare, I'm going to ask you questions, all right? Krishna, next one. 6, 8, 8. 10. What's going on?
It's just loading.
Yeah, you guys, I ask you guys to get ready, right?
I'm sorry, my Wi-Fi is just bad.
Oh. Did anybody choose 10? I don't see anybody choose 10.
I chose number 10.
Oh, okay. Who's this? Number 10?
Fadwa.
Oh, Fedora, not 12. Or someone is not choosing 12. Okay, Fedora, 10. Yes, we can see it. Go ahead.
Okay, so for number 6, you would use the power rule and the product rule on both sides. So y to the 5th becomes 5y to the 4th. And x squared, y to the 3rd, you would use the product
Y
rule
prime,
for.
right?
But
Y
before that, yeah,
5
you use the y prime for the y to the 4th. Yeah. So then for the product rule, it would be f g prime plus f prime g. So you would do x squared, then y to the 3rd prime, which is 3y squared, and you would put a y prime at the end, plus 2x, and then regular y to the 3rd. And on the other side, the derivative of 1 equals 0, and you would use the product rule again for x to the 4th y. So it would be x to the 4th, 1, and the derivative of y, which is 1, and you would add a y prime, and then plus 4x to the 3rd using the power rule, and then y. And then you would simplify what you get in the power rule, and you would get 5y to the 4th y prime plus 3x squared y prime plus 2xy to the 3rd equals x to the 4th y prime plus 4x to the 3rd y. And you would want to get all the y primes on one side. So you would subtract 2xy to the 3rd and add x to the 4th y prime. So then you would get 5y to the 4th y prime plus 3x squared y prime minus x to the 4th y prime equals negative 2xy to the 3rd plus 4x to the 3rd y. And you would factor out the y prime. So it would be y prime times 5y to the fourth plus 3x squared y squared minus x to the fourth. And then you would divide both sides by that. So the final answer would be negative 2xy to the third plus 4x to the third y divided by 5y to the fourth plus 3x squared y squared minus x to the fourth.
Perfect. Perfect. There's a little suggestion. You see,
Okay.
we don't like to start with a negative term. Maybe you can maybe the numerator you can write as 4x cubed y because that's positive term minus 2xy cubed.
Okay.
Great. Beautiful job. Thank you.
Thank you.
All right, next one. Rule 8.
Hi, can everyone hear me?
Yeah.
Okay, so we're giving the function cos xy equals 1 plus sine y, and we're asked to take the derivative of that. So I split it up into slides so we can see which side is which. So to differentiate the left side, we use a chain rule first. And so cos x is an outside function, and so it'll, oh, I don't know why it stopped sharing.
Oh.
Okay, there we go. So cos x is the outside function, and so we would get negative sine x, since we take the derivative of cos x, times the derivative of the inside function, which is xy. And so we use the product rule to take the derivative of xy, and so we get x times dy dx plus y times dx dx, which is equal to 1. And so once you simplify that, you get negative sine xy times xy prime plus y. And so then you put the whole function all together and you get negative x sine xy times y prime minus y sine xy. And so then we take the derivative of the right side. And so we get 0 since the derivative of 1 equals 0 plus d over dx times sine y. And then we use a chain rule and then we get cos y times y prime. And then we set them equal to each other. And so negative sine xy times y prime minus y sine xy equals cos y times y prime. And then we add the negative x sine xy, and then time the y. And so we add it to the other side, and then we get negative y sine xy equals cos y times y prime plus x sine xy y prime. And then to simplify the function further, we divide the other side by the cos y plus x sine xy. And so the dy dx would equal negative y times sine xy over cos y plus x sine xy.
Okay, great. Okay, for this one, you may write the negative sign up front. But you were saying simplified function. No, this is not function. This is equation. Right? Okay. Implicit differentiation is for equation because we do not have function to start with. So implicit differentiation is just for function, for equation, it's not function. Okay, great job. Anyone has any answer for this? This one is a little bit tricky because the cosine, the angle is xy. The angle will have to apply product rule. Okay, beautiful job. Thank you very much. Anyone has any question, feel free to jump in, all right, to ask. All right, let's see. So that's 8. Now 10, Fedwa 10. Anybody choose 12? Oh, Angel 12. Fedwa, are you there? All right, so let's start with, let's see who else. 12. Angel, let's start with you, 12. Because I think I was doing that on the spot. Then 14, I forgot. Oh, Ray chose 14.
Professor, it's me, Malika. I chose 14.
Oh, Malika chose 14. I'm so sorry.
Yeah.
Yeah, so sorry because I'm scrolling up and down.
Yeah,
So,
I know. It's okay.
okay, Malika, yeah. I mean, right, Malika, get ready. So Angel, are you ready? Okay,
Do you
great.
see it?
Yes.
Okay, so we take the derivative of both sides of the equation. For the left side, I use the power rule. So it will be 1/2 radical x plus y. And then since we take the derivative of y, we multiply that by y prime. And then for the right side, I use the product rule.
Hold on 1 second.
So,
Hold on 1 second. Yeah. Okay, so you're seeing, okay, you see this is a composition like, right? So you have something raised by half, then you get a 1/2 of the square root on the bottom. Now, what's the derivative of the inside of x plus y?
this one.
No, this one you get it from the half, right? Something raised by half. Then you take a derivative, you get this part. Yeah, you probably don't see my point. So it's not a y prime. What's the derivative? I'm asking, my question is, what is the derivative of x plus y?
2.
2? What's the derivative of x plus y? Derivative is 2?
Yeah.
Why? So, okay, what's the derivative of 2x then?
2.
So, but do you have 2x inside?
Inside?
Okay, x plus y, right? So my question is, what is the derivative of x plus y? It cannot be 2, right? 2 is for derivative of 2x, right? But x plus y is not 2x, right?
Yes.
So what is the derivative of x plus y? So why you get the y prime here? How did you get y prime here?
Because I have to multiply the derivative of y by y prime.
Okay, what is the derivative of y? Okay, let me ask you this. What is the derivative of x?
1.
1. What's the derivative of y?
And 1.
1 times y prime, right? So then it's y prime. So how should you fix this y prime here? You don't see a mistake?
Right here.
Right. You just told me derivative of x is 1, right? But where is the 1?
Because I use the power rule.
You use the power rule. Okay, you use the power rule. That's right. But what else? You use the power rule first, right? Something raised by half. Something raised by half. The derivative is 1 over something else. Okay, anyway, you don't see a mistake. Maybe later on you'll see it. Okay, keep going.
Okay, so for the right side, I got 2xy squared.
No. Explain this step. The step before that.
This side?
Yeah. How did you get the right-hand side derivative to be the dotted line?
I use the product rule. So the derivative of x squared times y squared plus x squared times the derivative of y squared, which is 2y, and then I multiply that by the y prime.
Okay, good.
And then here I cross multiply.
You cross multiply? Oh, I
Yeah.
see. Okay.
So y prime equals 4x squared times radical x plus 4xy squared times radical x plus y plus 4x squared y times radical x plus y times y prime.
Okay.
So I have to get all the terms with y prime on one side. I move them to the left. So I move this term to the left, y prime minus 4x squared y radical x plus y times y prime, and then move this, oh, this will stay on the right side. And then I factor out y prime, and then divided it by 1 minus 4x squared y times radical x plus y. Divide both sides of the equation by that. So I get this answer 4x y squared times radical x plus y minus 1 over 1 minus 4 x squared y times radical x plus y.
Okay. So this answer won't be right because you made a mistake here. 1, 2, 3 on the third line. On the third line, right? You apply the chain rule, right? You use the power rule and chain rule, right? Okay. So the power rule give you the first part, 1 over 2 square root of x plus y. But the chain rule part, you have a mistake. That's why I'm asking you, by chain rule, you have to take derivative of x plus y. What's the derivative of x plus y? That's a 1 plus y prime. So you're missing 1 plus here. Does it make sense?
Oh, here?
Right.
I
Because
get it now.
you get it now. Okay, okay, great. All right, thank you. Okay, thank you. That's the only minor mistake. All right, thank you. All right, let's see next one. Who's next one? Anybody has any question, you know, just jump in. So after Rudy, after Angel, who's the next one? Okay,
It's me, Malika.
okay, Malika, go ahead.
Okay, so we have to find the derivative of x sine y plus y sine x equals 1. So what I did was I used the oh, I forgot the product rule. The product rule. So I used the product rule to find the derivative of x sine y, which gave me x times cosine y prime plus 1 sine, and then I did the same for y sine x, and I got the derivative as y cosine of x plus y prime sine x, and then the derivative of 1 is just 0. And then I moved the terms without the y prime to the other side, and then I got x cosine y prime plus y prime sine x equals -1 sine y minus y cosine x. And then I just isolated y prime by divide. So I took it out and then I divided it on each side, and I got y prime equals to negative sine y minus y cosine x cosine over cosine y plus sine x.
Okay, a couple of comments here.
Yep.
You see, oh, okay, now I have this. You see, this dy dx does not make sense here, right?
Okay.
Because you have y prime. And also another suggestion, don't write y prime with the angle. Write y prime somewhere else.
So like in the front?
In the front, in the front of cosine. Because maybe later on, if you do a lot of questions, you get confused. You may think this y prime is part of the angle y.
Okay. Okay.
And also 1, right? You don't need to carry this 1, right? 1 times something doesn't change anything. There's no point to carry this 1 with you, right? With the sine y.
Okay.
Make sense?
Yeah. Yeah. That makes
Okay. So let me see.
Professor, could I add on something?
Yeah, and also there's mistake of this x.
Yeah, that was what I was gonna point out.
Oh, okay, thank you. Who says Malika, right? Malika,
Yeah.
where is this x? Where does this x go?
Oh, let me see.
Yeah, just let me know where should you add it.
Like you see y prime and then parentheses in front of the parentheses, so it's gonna be x cos y.
In front of parentheses or after parentheses?
No, like I don't know if I can share. Like here, I don't. Wait, let me see. Right here.
I cannot see your point. Oh, right. Now I see it.
Yeah, right here. So it's gonna be also here.
You mean after the close, after the
Yeah,
open condition,
yeah,
cosine y, right? So x should be here.
yeah,
Then x should be here. Great.
yeah, like that.
So you fix your own mistake.
Yeah,
Great.
yeah.
Thank you, Malika.
You're welcome. Thank you.
Okay, let's see. Next one.
I'm ready to do number 10.
Okay, great. Did I make you
Yes,
who's this?
yes, you did. Farwe, yeah.
Oh, Farwa, okay.
So gonna go through. Is that the right one? Hold on, sorry, wrong one.
That's okay. So let's see who's next one. Who's after 10? 10 is 12, right? Who chose 12? Oh, we just show 12. Angel show 12. Should be 4. So we're missing 14 only, right? Oh no, 14 and Malika just showed.
Yeah.
So that's it. Oh, has 16. Anybody choose 16? Okay, no 16 yet. So, somebody, I would need somebody to show 16.
There we go. Okay.
Okay, Noella wants to do 16. Great.
Okay, there we go. Okay, so this is number 10. We're gonna apply the product rule and the chain rule for both sides of the equation. And so on the left-hand side, we end up with d over dxy sine x squared plus cosine x squared times 2xy. And on the right-hand side, we have sine y squared plus 2x cosine y squared y, and d over dxy. And then we isolate, I guess, y prime. So y prime times sine squared plus cosine squared times 2xy is equal to, oh wait, no, I'm reading that wrong. So yeah, we're gonna subtract cosine x squared times 2x from both sides of the equation, so that you end up with y prime times sine x squared plus cosine squared, cosine x squared times 2xy minus cosine x squared times 2xy is equal to sine y squared plus 2x cosine y squared. I think I miswrote that there. With y times y prime minus cosine x squared times 2xy minus 2x cosine y squared times y and y prime. And to simplify all of that, we divide everything by yeah. Wait,
You
hold
can
on.
see
Yeah.
right?
Yeah. So you end up dividing everything by sine x squared minus 2xy cosine y squared. And so you end up on the left-hand side, you're able to cross out everything so that you're left alone with y prime. And on the right-hand side, because they both have the same denominator, you could just combine them, they're like terms. So you end up with y prime is equal to sine y squared minus 2xy cosine x squared over sine x squared minus 2yx times cosine y squared. Yeah.
Yeah, okay. That's a lot of expressions. All right. Anybody have any different answers? All right, great. Thank you, Fedwa. Okay, Noella, let me make you a presenter. Where are you? No, oh, here. Oh, let's see.
Are you able to see my work, Professor?
Yes.
Okay, so for this question, it was very lengthy, but I can walk through it. So the derivative of tangent x minus y is, I started off by taking the derivative of each component, each term. So the derivative of tangent x minus y is secant squared x minus y times the derivative of the input, which was x minus y, which was 1 minus y prime. And then I set it equal to the derivative of y over 1 plus x squared by taking the quotient, by doing the quotient rule, which was y prime times 1 plus x squared minus y times 2x over 1 plus x squared to the squared. And then from there, I multiply both sides by 1 plus x squared squared to cancel out the denominator, so that I would have one long expression to work with. From then, I rewrote so that all terms containing y prime were on one side, and then the other terms were on the other side, so that I could divide both sides to get y prime on its own. And then there was a point where I divided the whole expression by -1 so that I could get a positive y prime. From there, I divided the expression by 1 plus x squared plus 1 plus x squared squared times secant squared times x minus y on both sides. And then I got a y prime equals to 2x plus 1 plus x squared times secant squared x minus y over 1 plus x squared plus x plus 1 plus x squared squared times secant squared minus secant squared x minus y.
Great. Yeah. Yeah, I would like an explanation like that. You know, we don't really have to read each step, but to tell what's going on with each step. Okay, great. Anybody has different answer, or anybody has any question? Okay, great. Thank you. All right. So beautifully done and very well. Anybody has any question? You know, I'm worrying about those people who hasn't presented yet. Let me see. I have people presented like 5 times. I have people not presenting anything yet. All right. And let me see, what is this? All right. Okay. Anyway. Okay, before I start new material, anybody has any question regarding homework or regarding the material we were talking about? So far we talked about we covered the limits. We talk about differentiation with functions, and differentiation, you know, sometimes we don't get functions, we get equations. So we have this implicit differentiation. Okay, Amia is asking a question. If we are doing problems next time, we have to ask beforehand. No, usually, you know, in the morning, I would say, I would ask people to write the numbers on the chat. All right. So next time, maybe today I don't leave you. Yeah, so I leave you some questions for you to present, right? So in the morning, early morning, I will ask you to write down the numbers on the chat. Then we just follow that. So probably you come to the classroom a little bit earlier to claim your number. Or otherwise, other people already claimed. So you don't get a chance to show it. But however, let's say next time maybe we'll do this. If one person, the work has a mistake in it, you do not agree with her answer. So maybe next time I do not point out the mistake. So I'm going to ask you if you agree. So in that case, I give you more people to show. Okay, if you have different answers, maybe you can show too. In that case, one question, I can have different people to present. Okay, let's do that next time. So next time, I'm not going to give comments at first for one person's work. So I'm going to ask you to give comments. All right. If everybody agree, so we just pass on. If somebody made a mistake in the presentation, that person still get credit. But then you are able to point out the mistake. You are able to explain, what's the mistake, what should be the right answer, and also you get credit. Okay, next time we will do this. All right, and okay, let's see. Key is saying we cannot. You can only see the most current comment after you joined. Yeah, we're talking about one question after another, right? Okay, all right. All right, so next time we'll do that. So today, so anybody has any questions so far? Again, I'm encouraging people to show, to present, all right? And if you really fell behind of this class, all right, you haven't mastered to to take the limits of a function, to differentiate a function, or to differentiate an equation, you need to catch up. Watch videos, watch YouTube videos, or watch the recordings we have in this class, or to go to the not to go to Docene Center, to get in touch with Docene Center. They will have tutors to help you out. All right. So today we're going to talk about the applications of differentiation. Right? We know how to take a derivative of a function. We know how to differentiate an equation. How do we use them in life applications? So that's our topic for today. Okay, something is called related rates. So this is an application for implicit differentiation. Let's see some example. It's called related rates. What does this mean? Think about it in an equation. That's in a circle, right? We have x squared plus y squared equals to 1. Related rates means this. How is the change of one variable, affect the change of another variable? So we call related rates. Rates means rate of change. Related means, those two variables related in certain way. Let's see in a circle, right? X and y, those two variables related in such way. X squared plus y squared equals 1. So how is their rate of change related? Now we know how to take an implicit differentiation. We said, okay, if I differentiate this equation, I get 2x plus 2y, y prime equals to 0. Right? Implicit differentiation. Then I simplify this a little bit. So I have, or you know what? Let me actually go from this one. Maybe I attach x prime. In this case, in related rates, we want to write related. Okay, I have to mention one thing. That's invisible related rates. There is an invisible variable. Okay, we can think as time. We can think the variable is time, t. You know, at this point, let's understand as a point t, as time t. So in this case, this x prime is dx dt. The y prime is dy dt. It's a little bit strange, right? Because in implicit differentiation, we said this is 2x, we ignore dy dx. Because in that case, we will only consider the rate of change of y in terms of x. Let's put this way. So this part we know. We said, okay, when I differentiate, I want to find dy dx or y prime. That's our consideration. In that case, we get a 2x, dx dx, just 1, we ignore it. So plus 2y, y prime equals to 0. Then we solve that. We said, okay, y prime is equals to negative x divided by y. So this much we know so far. Let me put this one here. Okay, with the implicit differentiation, we said, okay, if you give me x squared plus y squared equals 1, the unit circle, I can find dy dx. I can find dy dx. In that case, I call that y prime. Dy dx is my y prime. I differentiate the equation. So in the end, I get dy dx. The rate of change of y in terms of x. The rate of change of y in terms of x. So dy dx, y prime here, equals to negative x over y. So this, so far, we know about this. With related rates, that means, y in terms of something. Well, let's understand as time for this moment. So we want to consider, so in this case, we maybe call y prime as dy dt, and x prime is dx dt. So there's a third invisible variable there. So we want to consider the change of y in terms of the variable, the change of x in terms of the variable. All right, so this is new. So this is called related rates. Related rates. So now let's use related rates for the circle. Right? So related rates for the unit circle. So how should we think about it? Let's think about it. We have a circle here. We have a circle here. Let's think about a point on a circle. A point on a circle. Right? So of course, this point has x value, y value. Imagine I put this on the xy plane. Right? So this point has x value, y value. Let's think, okay, we start the point here. Then we're going to move around move the point around the circle. Right? So now we have third dimension to think. We have third variable to think, time. So x change in terms of time, y change in terms of time. We have the relation of x squared plus y squared equals 1. But now we introduce a third invisible variable. Right? So okay, I'm considering change of x in terms of time, change of y in terms of time. And we call this related rates. So in that sense, I use lazy notation x prime, but my x prime is not dx anymore. My x prime is dx dt. How is x position? How is the x value change in terms of t? When I move around the circle, right? How is x value change in terms of t? And the y prime, I'm going to call dy dt. How is y value change in terms of time? So even we still use x prime, y prime in this case, but that one is in terms of t. All right, so dx prime is dx dt. Y prime is dy dt. The rate of change each variable in terms of another variable, which is just invisible. So this is related rates. Related rates. Now, let me give you another example. We remember Pythagorean theorem, right? Give us a right triangle. Think about the right triangle. We have the sum of two legs squared. So A and B are two legs, and C is the hypotenuse. So have this A squared plus B squared equals to C squared, right? So have this triangle, right triangle. I have this right triangle. Oops. I need one more line. Okay, I call this side A. A is my altitude, height. I have this B, my base. I call this hypotenuse C. So I have A squared equals B squared. A squared plus B squared equals C squared, right? So now, this triangle, think about it, we have a piece of string, right? Think about it, we have a piece of string. We can make this triangle. So that means the parameter of this triangle will not change. But we can change the shape, right? We can change the shape. Maybe I change this one longer or shorter, right? Then I have to change this. I can change this one accordingly. Just imagine we have a piece of string. The parameter, the length is fixed. Then we use this piece of string to make a triangle. To make a right triangle, and then we can reshape these three sides, right? The parameter does not change, but the three sides can change accordingly, and we can change all the three sides. So then if we do that, we will introduce three more variables. The rate of change of A, which is dA dt. The rate of change of B, let's call it B prime, this is lazy notation, dB dt. Similarly, the change of the hypotenuse, which is dC dt. We have these three more variables. And so the relationship between A, B, C is this: A squared plus B squared equals C squared. And now we use the idea of implicit differentiation. But we will consider A prime, B prime, C prime. So we can write as 2A, A prime, plus 2B, B prime, equals to 2C, C prime. So this is called differential equations. Okay, it has this rate of change in it. Differential equations. If you're a math major, in the future you're going to learn this. So you can simplify this, right? Everybody has a factor of 2. Just forget about this 2, right? We divide by 2 for every term. We simplify this equation, so that becomes this. So A, the altitude times the rate of change of A plus B times the rate of change of B equals to C times the rate of change of C. Okay, so out of this, you get a differential equations. And with this equation, we have 6 variables. We have A, B, C, we have A prime, B prime, C prime. So in life, sometimes we consider, okay, so let's think about this side. The A side is a wall. A side is a wall. Maybe a person, think about a person walks along this B, right? The person walks longer. Or maybe think this way. Think about a ladder, right? A ladder lean on the wall. And this C does not change. The length of the ladder will not change. But maybe we can slide down the ladder, right? We can slide down the ladder. You see the triangle before. Let me keep the triangle before. So this is the original position for the ladder. Okay, so the original position of the ladder was here, but maybe we slide down the wall, right? The length of the ladder will not change, but you see the altitude changed, the B changed, right? Because the ladder is a constant, the ladder C prime will be 0 because it does not change. But the A will change, the height will change. So that's this new triangle now, and the B will change. So we're talking about rate of change, all right? Okay, let's see first example. Any questions? Just a new idea, rate of change, okay, rate of change, related change, related rates. The T in this case, just rate of change, related rates, okay, related rates in terms of T. Let's put this way. Related rates, right, introduce another variable T. Now let's see an example. Example 1. Air is being pumped into a spherical balloon, right? Spherical balloon. Think about, someone's birthday party, you blew the balloon. So that its volume increases at a rate of 100 cubic centimeters per second. All right, so this gives us the rate of change of the volume. Let's call the volume of V. Let's call the volume of V. V, how do we find a volume for a balloon? If you remember, that's 4/3 pi r cube, right? Right here. So the formula for volume of a sphere is 4/3 pi r cube. So you can think of V is a function in terms of R here, because pi is just a number. Yes, sphere formula. So we know that. So we have this. So we have this formula. Then we can talk about V prime, right? V prime. But this V prime is not dV dr. Of course, we can think about dV dr. But because we're talking about related rates, because we want to see, how is this volume change, the volume change related to, because the question is how fast is the radius of the balloon increasing when the diameter is this much? So what is the instantaneous rate of change of the radius if knowing the volume change? Knowing the volume change. So this one, we only have one variable. This is the function. This is easy to deal with, right? This is a function. Let me write it down here. So this is a function. So this question actually is easier to deal with. So v is a function of r. V is a function of r. So just take a derivative with dv dr. But let's do that one first. Let's do that way first. Let's not use implicit differentiation yet. Because v is a function of r, we don't have more than two variables yet. We don't have, it's a function. It's easy to deal with. Let's use our old method. So v of r equals 4 over 3 pi. I'm going to use this pi r cubed. And we know exactly how to take derivative of this. So v prime of r equals to 4 over 3 pi times 3 r squared, right? Times 3 r squared. So that becomes just 4 pi r squared. Simplify the 1/3 with 3. This is 4 pi r squared. Okay, so what is the problem? What is the problem? We have a function, right? So this is the function. V, the volume is a function in terms of r. And we use our old skill. So we know how to take a derivative of v. And the derivative of v in terms of r is 4 pi r squared. But the question is, how fast is the radius change? We're looking for the rate of change of r. We're looking for r prime. So what is the problem to use our old skill? Do we see r prime? We don't see r prime, right? So that's why we're able to use the old trick, but we also need to attach r prime. But this r prime is not a dr. So in this case, we just introduce another invisible variable. So v prime here is dv dt, and r prime here is dr dt. All right, now it makes sense. Otherwise, it doesn't make sense because from before, we only consider the change of v in terms of r. So we have dv dr, then dr dr, which is 1. But now we want to find the rate of related rates. Related rates. How is one change in terms of another thing change? So treating this as, so we attach r prime here. And this r prime is dr dt. Okay, so basically we just manipulate, all right? Manipulate this. Okay, so v prime is given, right? V prime is 100. You can tell from the unit. The unit is cubic centimeters per second. So that's a speed, right? That's a velocity. That's the rate of change. That's the rate of change of the volume. Okay, the 100 is given. So V prime is 100 equals to 4 times pi. And R is given. When the diameter is 50 or when R is 25, what's the instantaneous rate of change of the radius? So R is 25. So 4 times 25. Then we need to put R prime here because we're looking for R prime. Okay, then we solve for R prime because R prime is our only variable, right? So 100 divided by 100 on both sides, that's just 1. So we have 1 over pi. Okay, this is why we need related rates.
Professor,
Yes.
where did that square go on the arm?
Oh, I forgot.
Yeah, 25 to the
I made a
square.
mistake. Thank you very much. 25 square. The square, I ate it. 25. So now, so 25. So we have 1 over 25 pi. Thank you very much. 1 over 25 pi. Thank you. Good eye. Okay, pi is pi. We just leave as pi. So R prime, so the rate of change of R is 1 over 25 pi. All right, so what's new from the implicit differentiation is this invisible third variable. All right, otherwise we won't be able to find the rate of change for R, for the radius. Any questions? All right, so from now on, we just, for related rates, not from now on, for related rates, when we want to consider, how is each variable change in terms of time, most of the time we use is because of time. Well, if we have, but for now, right? For now, let's just do in terms of time. And then we introduce every variable a prime, a rate of change for the variable. But also, we can think about this, right? So now here we have 3 variables, A, B, C, for the Pythagorean theorem. Maybe sometimes we want to say, okay, I just want to consider the change of B, change of C in terms of A change. But sometimes we want to consider the rate of A, rate of B in terms of C change, right? In that case, just take one, take one, we can talk about dB, dA, dC, dA, dB, dB. Or we can talk about dA, dA, dB, dA, dC, dA, right? Or we can talk about dA, dC, dB, dC, dC, dC. Once we know implicit differentiation, so we have this free choice. We can consider one variable change in terms of another, or even one variable change in terms of the invisible one. Most, life applications is time, in terms of time. All right, let's see more examples. Example 2. Example 2 is in a ladder 10 feet long rests against a vertical wall. So vertical wall means, we'll assume this is the corner of the ground, and the wall makes 90 degrees, so we can work with right triangles. If the bottom of the ladder slides away, so imagine this is the ladder, the bottom slides away, and of course the y will change, right? Slides away at a rate of 1 feet per second, rate of change. Right? If we use y for the height, that would be y prime. This is y prime is given. Question: how fast is the top of the ladder sliding down? Oh no, this is sliding away. Sliding away is x change of x. Change of x. The base we use x to represent the height, altitude. We use y to represent when the ladder slides away. That's x prime. Change of x. The question is asking how fast is the top of the ladder? The top of the ladder sliding down. which is the y change, the y prime. Sliding down the wall when the bottom ladder is 6 feet from the wall. So imagine we have imagine this is a new ladder now, right? So now x value is 6. From here to here is 6. From the corner to this ladder, bottom 6 feet. So x equals to 6. So x equals to 6, and also x prime is given. X prime or dx dt is given as 1, right? Sliding away. The ladder slides away from the wall at a rate of 1 feet per second. So x prime is given. Changing of y is given. Let's put it over here. Right. So this 2 is given. So we want to use Pythagorean theorem, right? Pythagorean theorem. Right here. Pythagorean theorem give us this. X squared plus y squared equals 100. Right? Because the ladder C does not change. The ladder 10 feet long stays 10 feet long. So 10 squared, 100. Then we take a derivative with this. We use the implicit differentiation. So we got 2x dx dt or x prime plus 2y dy dt or y prime equals 0. Simplify, we get a dy dt or y prime equals negative x over y x prime dx dt. Then we just plug in the ones we know. We're trying to find a dy dt, right? So x is given 6. From x, we can solve for y, right? If x is 6, hypotenuse is 5, we know this has to be 8. 3, 4, 5 makes triplets, Pythagorean triplets. So y equals 8. 6 is 2 times 3, 10 is 2 times 5, so y is 2 times 4. 3, 4, 5 is a Pythagorean triplet. So y equals to 8, or we can do y equals to 10 squared minus 6 squared square root, right? 10 squared 100, 6 squared 34, 100 minus 36, 64, square root of 64, that's 8. All right, so we have 6, we have 8, and the dx dt is given. Dx dt is sliding away 1 feet per second, right? So just plug into this, so we get negative 6 over 8 times 1, which is negative 3 over 4. So you see the speed is negative, right? And velocity, what does it mean the velocity be negative? That means the length of y is decreasing. The rate of change is negative. You see the y is decreasing. The y value is decreasing. All right, so the negative value means the value of y is decreasing. You see x prime equals 1 is positive. That means x value increases. X value increases. All right, any questions for this? Okay, let's see more example. Example 3. A water tank has a shape of an inverted circular cone, like an ice cream cone, with base radius 2 meters. So this is base radius 2 meters, and the height 4 meters, and the height 4 meters. If water is being pumped into the tank, so water is being pumped into the tank at a rate of 2 cubic meters per minute. Now, what is this change? The volume, right? Water being pumped into it. So the volume of water in this cone is increasing. Is increasing. The volume is positive. Is increasing. So V prime of the water equals to 2. Find the rate at which the water level is rising when the water is 3 meters deep. So at this moment, the water, the height is 3. So think about h equals 3 at this point. All right, h is 3. Well, this picture is not looking right? The picture maybe should be here because the total height is 4. The picture maybe should, make this water a little bit higher, maybe here, right? But anyway. Okay, so now we have to consider the rate of change of R. So we want to find the rate at which the water level is rising when the water is 3 meter deep. So we want to find h prime. Right? We want to find h prime or dh dt. So dv dt is given. dv dt is given. Okay, what is the formula for a cone? The formula for a cone is v equals to 1/3 of pi r squared h. How many variables we have? We have 2 variables, right? So in this case, we haven't learned it yet, but when you go to 250, class 250, you will learn this. It's called vector valued functions. So this also is a function, but this is a function with 2 variables. All right? This is a function with 2 variables. But at this point, we don't know how to deal with function with 2 variables yet. So we're going to treat this as an equation to use implicit differentiation. We're going to take derivative with everyone. So take derivative with v prime. So dv dt equals to 1/3 pi times, well, product rule, right? See, we have r squared h. So let's use product rule. So for r squared, 2r prime. And take derivative with everyone. Attach its rate of change. Plus, times h. Right? Plus r squared times derivative of h. Well, derivative of h is 1. 1 times h prime. That's h prime. So using implicit differentiation and related rates, so we get this. We take derivative with everyone, with v, with r, with h. We attach its rate of change, which is v prime, r prime, h prime. So product rule give us this. So now we have v prime equals to 1/3 pi times 2r r prime h plus r squared h prime. So now we have 6 variables. So we have 6 variables. What is our goal? Our goal is to find the rate of the deep, so which is h prime. So our goal is to find h prime. This guy. So that means we have to first, to be able to solve for h prime, we need to know r, we need to know h, and we need to know v prime. V prime is given as 2. Let's put the ones we know. So v prime is given as 2. Because 1/3, 1/3 on the other side, right? I'm going to multiply 3 on both sides. So I'm going to make this 6. So I don't have to write 1/3 anymore. I multiply 3 on both sides. I get 3v prime equals to pi times this term. So v prime is 2. 2 times 3 is 6. So I don't have to write 1/3 anymore. Pi times, also I have this 2. Let's simplify 2. So I divide by 2. I still get 3. Pi times, I don't know r at this moment yet. I don't know r prime at this moment yet, but I know h. I know h. H is 3, right? H is 3. So plus, hold on a second. I don't have a 2. That's r squared. I don't have 2. So I have 2 times 3, I have 6 here. H is 3, right? 2 times 3, 6. 6 R prime. I don't know R prime yet, but I'm going to find them. And R square, I don't know either. R, I don't know. H prime. Okay, so far we're able to come up with this equation. So I have 6 pi, 6 equals to pi times 6 R prime. This 6 comes from 2 times 3 because I multiply 3 on both sides. I get rid of this 1/3. V prime is 2, so 2 times 3 I get 6 pi, right? 2 R prime H. So H is 3, 2 times 3 6 R prime plus R square H prime. So my goal is I need to find R prime. So how do I find R prime? Let's go back to this picture. So in this picture, I have a similar triangles. You see I have this triangle, right? This size 2 and this size 4. And I have this triangle R and 3. I have similar triangles, right? I can solve for R. So similar triangles, the corresponding side have the same ratio. That gives me 2 divided by R equals to 4 divided by 3, right? So this is 4, this is 3, 4 divided by 3 equals to 2 divided by R. So I can solve from this relation. Then, so 2 divided by R, so I get a 4R, right? Cross multiplication equals to 6. Or R equals to 3/2. Did I do it right? Yeah. 2/R is 4/3. Cross multiply, I have R times 4, 4R, 2 times 3, 6. So R equals 3/2. Okay, so now I know R, but do I know R prime? I don't know R prime. How do I get R prime? Also, so now we get R, right? R equals 3/2. But how do we get R prime? Let's also use the Pythagorean theorem. Pythagorean theorem is saying, okay, I have, let's see. Let's use R and H. Okay, so this side is R, this side is H, right? So R squared plus H squared equals to the sides, the hypotenuse square, right? So let's see this one. Let's see, just at any time, right? At any time equals to, let me call this C, okay? Just for this moment. So I have R squared plus H squared equals to this square. So I don't need to use that. Let me use another equation. Let's use an easy equation. So you see, we have this, right? We have 2 over R equals to 4 over H. 2 over R equals to 4 over H, right? We have this equation. I'm still using the similar triangles. At any point, at any time, I have this R as variable, I have this H as variable, right? At any time. So I have 2 over R equals to 4 over H. So I have this relation. Now I can take a derivative with this. Well, let's do cross multiplication. That gives us 4R equals to 2H. That gives us H equals to 2R. We have this relation, right? So I should start with this. I should start with this, with the relation of the side, of the height, and the radius. You know, if I start with this, I get this relation h equals to 2r. Right? Then I don't have to do this anymore. H equals to 2r, so I get r and r prime. So I use the implicit differentiation, take derivatives of this. So I get h prime equals to 2r prime, right? The derivative of h is 1 times h prime. Derivative of 2r is 2 times r prime. So rate of change of r, h prime equals to 2r prime. Okay, so I have these two relations. So now, if h equals to 3, at the moment, at a particular moment, h equals 3. H equals 3 implies r equals to 3 over 2. Right? And from here says r prime equals to h prime, because my goal is to solve h prime. R prime equals to half h prime. Well, let's substitute, right? Substitute into this. So now 6 equals to pi times 6 times r. R is 3 over 2. Right? 6 times 3 over 2, that's 9. Then what's r prime? R prime is half h prime. So that's half h prime plus r squared. R squared is 9 over 4. 9 over 4 h prime. We're able to come up with this equation. Right? What is factor h prime? Factor h prime. So h prime equals to 6 divided by 9 over 2 plus 9 over 4. Well, that's 18 over 4 plus 9 over 4. That's a 27 over 4. 27 over 4 pi. Right? So I factor out h prime. Then I divide both sides by the factor of h prime, which is 6 divided by pi times 9 over 2 is 18 over 4 plus 9 over 4 is 27 over 4. So 6 divided by 27 over 4 pi. We'll simplify this a little bit. Simplify this a little bit. So we get equals to 6 times, well, let's divide by 3 first, right? Divided by 3, we will get 3 over, no, 2 over 27 divided by 3, 9 over 4 pi. Right? 9 over 4 pi. Right? See, my numerator has 2 other factors. My denominator, 3 other factors. My denominator 27 has 3 other factors. So I'm dividing by 3. I got 2 over 9 over 4 pi. Now, 2 divided by 9 over 4 pi is 2 times 4 over 9 pi. That's a over 9 pi. A over 9 pi. Okay, that's it. That's our h prime. Oh, did I make a mistake? Did I make a mistake? Let's check. So 6 equals to this, right? So 9 over 2 h prime plus 9 over 4 h prime. 9 over 2 is 18 over 4. 18 over 4 plus 9 over 4 is 27 over 4. Then 6 and 27 has a common factor of 3. So I divide by 3. I simplify to be 2 over 9 over 4. Now 2 divided by 9 over 4 pi is the same as 2 times 4 over 9 pi. So 2 times 4 is a over 9 pi. I think this is right. Okay, a over 9 pi. So that's our answer for h prime. So any questions? Right, so this goal is to solve for h prime. So I'm going to encourage you to go about to solve for r prime. And of course, if we solve h prime, we go back to this equation, right? We can find r prime. R prime just half of h prime. Half of h prime, which would be 4 over 9 pi. Another way go about this is just substitute h into r, right? Sometimes maybe the question asks, find the rate of radius change, right? So then we go about with r. We substitute h into r to solve for r. Okay, any questions for this? Hold on 1 second. Maybe I made a mistake somewhere. Let's see, h prime, 6 divided by this. Let's see the answer of the book. 8 over 9 pi. It's right. My answer is right. Okay. It's the book has 8 over 9 pi. It's the right answer. All right. So let's see the strategy. The strategy is read the problem carefully, draw a diagram if possible, introduce notations, express the given information, write an equation with related rates, use the chain rule, differentiate both sides, substitute given information. All right. Okay, let's see example 4. You know what? We don't really have much time. Yeah, we don't have time to practice here. So I'm going to talk about example 4. I'm going to leave you some questions. You can do it, and so you can present it next time. So let's see this example. Car A is traveling west. Okay, car A is traveling west to C, right, to the destination of C. And the car B is traveling north. Car B is traveling north also to the point C. So car A is traveling with this speed, 15 miles per hour. All right, 15 miles per hour. So if we call car A to the distance of car A to C, so X, we call this X prime. 50 is for X prime. And B to C is Y, so we call Y prime. So Y prime is given. X prime is 50, Y prime is 60. Both are headed for the intersection of the two roads C, so intersection C. Question, at what rate are the cars approaching each other when car A is 0.3 miles? So that means car A is 0.3 miles from the intersection C. That means X value is 0.3. And car B is 0.4 miles from the intersection. Car B means Y equals 0.4. Okay, we see a right triangle here, right? Right triangle. Let's call the distance from A to B Z. So we form the equation Z squared equals X squared plus Y squared by Pythagorean. Then we differentiate this. We differentiate this equation. We have 3 variables, right? So we do 2z, z prime, equals to 2x, x prime, plus 2y, y prime. So z prime we solve, that equals to 1 over z, x prime, plus y, y prime. Now, just substitute all the knowns. So x value is known, 0.3, y is known, 0.4, and x prime is 0.5. X, let's see. So this is 50 miles per hour. This is also miles. Okay, so the units agree with each other. So dx dt is 50, dy dt is 60. So dz dt or z prime equals 1 over 0.5. Where do you get 0.5? Because x is 0.3, y is 0.4, and of course z, the hypotenuse at the point, is 0.5. So 1 over 0.5, then 0.3, x is 0.3 times dx dt. Okay, why this is a negative? Negative 50. Why the speed is negative 50? And also why this is negative 60. This will have to be very careful. Because you see the distance from A to C is decreasing. That's why the rate of change is negative. The distance from B to C, Y, is also decreasing. Okay, that's why it's negative. So remember to use the negative sign. So that's why 0.3 times negative 50, 0.4 times negative 60. So after we solve, so dz dt is negative 78. The distance between A and B is getting smaller, right? It's decreasing also. It's decreasing. And in the end, at the C will become 0. They will meet. A and B will meet. So that's why it's negative. Negative. All right. Any questions? So rate of change of one variable. When the quantity of the variable decreases, the rate of change would be negative. So that's the one thing we need to be mindful. Okay, example 5 is similar. Let's talk about example 5. Then I'll leave you some questions. Let's see example 5. So imagine a man walks along a straight path at a speed of 4. So let's think about the man walks from here, right? So this might be the starting point. Then walks along this path and makes a distance of x. So his speed of walking is 4 feet per second. So the distance is increasing, or that's x prime or dx dt. But such light is located on the ground 20 feet from the path. Okay, so a light is here. It makes the distance drop a perpendicular line to the path. Right, so the distance is 20. So this is fixed, because we're not going to move this light. The light stays here. So the distance from this light to the path is constant, 20. And the light is kept focused on the man. So it rotates. The position of the light does not change, but its angle changes. So it rotates. So the light focuses on this man. When the man was here, the light facing this way. So when the man walks away from the point, the angle rotates. So it makes an angle theta. Question: at what rate is the searchlight rotating? When the man is 15 feet from the point, so now when the man is 15 feet from the point on the path, close to the searchlight. All right. So we see again we have this right triangle, right? But now we're talking about the angle theta. So we want to find the change of the angle d theta dt or theta prime, d theta dt. So what do we have? We want to use the tangent value. So tangent theta equals the opposite over adjacent. Adjacent is 20 fixed. X keeps changing. So we have tangent theta equals to x over 20. Well, we can rewrite it as x equals 20 times tangent theta. Then we take derivative, right? X prime or dx dt equals 20 times the derivative of tangent theta. Derivative of tangent is secant square. Then we'll attach with theta prime or d theta dt. We're trying to solve d theta dt. So d theta dt equals 1 over 20 times 1 over secant square will be cosine square theta, right? dx dt. Now let's substitute all the things we know. So 1 over 20, then cosine. We do not know the angle yet, but we will find out. So cosine square theta times the speed of the man walking, dx dt, which is 4. So get a theta prime or d theta dt equals 1/5 cosine square. So now the theta changing is in terms of the theta, the angle itself. So how do we find theta? Well, when x at the moment x equals 15, x equals 15, right? Then we have x, we could go through tangent, or we could use a cosine. Cosine theta equals to 4/5, right? We have 20, we have 15, let's put 15 here. 20 is 4 times 5. 15 is 3 times 5. So have this 5 times 5. So this side get 25. We could use 20 squared plus 15 squared, then square root, right? Pythagorean theorem. Look at 25. And so cosine theta equals to 20/25 or 4/5. We just substitute into this, right? So we have 1/5 times 4/5 squared. 4/5 squared. Simplify, we get 16/125. Right? So it's 0.128. So the rate of change of this light rotating, right, is 0.128 radius per second. All right, because we use a radian here. All right, any questions? Okay, that's related to rates. Let me find some questions, leave to you for next time. You can show this. Let's see. Okay, the first one is interesting. Let's do 2, 4, 5. So to present next class. So two will mean 2 people. Okay, A and B, 2A, 2B, 4, 5. $12, 14. How many questions? 1, 2, 3, 4, 5, 6. 15. 20. Okay, 1, 2, 3, 4, 5, 6, 7, 8. All right. Okay, 8 questions, all right, for next class to present. So 2, 4, 5, 12, 14, 15, 20. All right, any questions? Okay, if no questions, we end here, all right? I'll see you on Thursday. Okay, question, go ahead, ask. Oh, where can you find the recordings? Okay, let me show you where can you find the recordings. Let me share with you this. Okay, you see we're here right now, right? Go to, let me stop.